Hi YouTube. I just wanted to share my project here. It's a STM32 development board. Reason for sharing my project is to act as a portfolio. This is not my main profession, but I'm trying to crack into the embedded engineering field. This is my take on the STM32 development board from Phil's lab. They're very similar. Really the only change is I've added a CAN transceiver just for my purposes. I'm trying to do a bit of automotive work. The components aren't an exact match to one used in Phil's tutorial, just using what I could purchase locally. It seems to be going all right so far. I use mainly 0805 components, so I can swap values out easily if required. I soldered the board together using this MHP 50 heat bed. It's worked really well, heats up nicely. And yeah, I was able to do a bit of rework when I was having a few shorts at the start. But yeah, the rework worked really well for it. Programming the board, I've used my STM32 Nucleo development board. I've removed the jumpers up here, and at the same time I got this board made, I also got this this little board made, and it just breaks out the serial wire debug connectors and brings it into this little connector up here. So just plug it in like so, and then yeah, comes along and just allows for a nice smooth setup. Then yeah, and I've just got a little plug here to connect up to 12 volts. From there, I won't really bother showing you the schematic because it's pretty much just what we use off Phil's lab. But yeah, I've been programming it initially with the STM32 Cube IDE just to get it up and running, make sure it worked. And then I've moved over to a Linux environment and trying to program the board in that environment, just trying to get away from the Cube IDE just to become more familiar with the ARM toolchain and yeah, going that way. So I'll walk you through what I've done there. So yeah, over in STM32 Cube IDE, I created a normal .ioc file. So use the whole project, went through, select all the peripherals, the external crystal, and that's what I've labeled as my _how file here. So you got that to generate all the code, and yeah, and then with that, I then went over to STM32 Q programmer, selected ST-Link and connected to my Nucleo board. Picked it up fine. One thing I do notice is it doesn't detect the voltage on the board. I'll have a look at the schematic, and yeah, I don't think that's connected. It is a known issue that I've seen in the community forum on the STM32. Anyway, so yeah, open the file, the .l file for this project, and then yeah, it flashed it, and yep, it flashed and worked well. After that, so now that I knew that it could work and I had my handheld, I then from there I created another project without using the how libraries. So that's where yeah, I had to do my own include and write to the registers directly myself. And yeah, so use that, compiled, generates the .l file, and then yeah, same thing into the Q programmer, open the new file, and flashed it, and yeah, it worked. So now I knew that I could write to the board, and I'd written up a basic main.c file that yeah, I was successfully writing to the right registers, and away we went. So from there, then I moved over to the Linux environment and was going to start writing to the using the ARM toolchain compiler itself. One thing I did find, and I do recommend having a read of this, was this book, The Definitive Guide to ARM Cortex-M3 and Cortex-M4 Processors. Apologies if I get the name wrong, by Joseph Yu. Really good book, not too heavy, a lot of detail, and it was pretty easy to read. I recommend reading all the chapters, but down at chapter 15 is when they start implementing some code and writing to the compiler, writing to the processor microcontroller itself. And so they've got chapters for each one, and then getting started with the GNU compiler collection. So yeah, really good. Breaks it all apart for you. Really good description on what files you need to grab. And yeah, so these files here, the linker and assembler, they're files that are auto-generated in this project. So when I go to the Linux environment, they're files that I've brought over from this project. So we'll head over there. First things first is you need to go to the downloads page and download the GCC compiler, which is what I've done. Most of this or pretty much all of it, is taken from the YouTube channel Artful Bytes. So if you go, he's got a really good video on setting up a tool chain. This is what I've pretty much done. So I've downloaded the toolchain for this environment, and then I go unpack it. I'm just going to use the file explorer just to speed things up, a bit easier to display. So created a dev folder, and I've moved it into the tools, is the compiler. So you can see the compiler in here. GCC. So yeah, there you go. So that's where the actual compiler now is. And then created a software folder where I've put my project. And so in here we have chip headers. So chip headers are going to be all the files that ST provides. That's this is where you can go to the ST website to download that. So I've moved them in here, and then I've moved my bare metal project that I had in the Windows operating system over to here, and then so I use that as a template to grab what I needed. So like the flash linker script, for example, I just grabbed it out of there. So anyway, so I created this makefile folder, and I've copied the minimum files that I needed. So I've got my main.c, I've got my makefile, I have my startup script, which is provided by ST, the linker for the linking it to the flash location, and then there's syscalls and sysmem. I'm currently compiling the sysmem, but I'm not compiling the syscalls yet. That's something that I'm working on. So within the makefile, we'll just give a quick overview. As I said, Artful Bytes has a really good write-up on this. So here is the compiler location, the CMSys directory, and the device directory. So anything I need for the includes, and so here I've gone through it and created the compiling scripts. These are built from pretty much looking at what ST is outputting. when you hit compile and you see the display at the bottom of the qbyte, but you can also go into there's a file there's a window in qbyte that you can go and see what arguments and stuff it will be linking, applying when it does its compile. So I used a mixture of that and also what was in the book that I mentioned earlier. So this is where I've gone through and put all these arguments in. And so yeah, so compiling creating the main.c file here, or the main.o from the main.c, and then yeah, creating the sysmem.c from the .o from the mem.c, and same thing creating the blink elf file from all these input arguments. So now when I go within my terminal, I can delete my blink, and then I can go run make, and here is the output, and there's my make file. So from here I will now go program the board, just to show it's working. So here we are set up. I've got my board, it's powered up 12 volts just with the power supply off screen, and I've got my nuclear board plugged in. So yeah, here it is flashing away. So the operations that I do, if I want to make a change, so I can then, over in my terminal, I can open up the main.c file, and just so for example, let's take a factor of 10 off the flashing rate. So I'll save that, just closing that. So I run make, and so it's detected that there's the main.c file has changed, and then produced a new main.o file, and then it's identified the main.o file has been updated, so it has to update the .elf file. So then over in STM32 programmer, I connect to the board, and then I'll just close that because that was an old file. I'll open up a new file. So that's the date modified, 10:15, matches. Open that up. I download. So download successful. I disconnect, and then I just have to power cycle the board. So I'll do that off screen by turning off the power supply. Power's died. Bring the power back, and there we are. We can see the increased flashing rate. So from here, the next steps would be to download OpenOCD and use GDB. These are open source debugging software as far as I'm aware, and this will help me when I'm debugging new code. I can use that within the Linux environment rather than having to use the GUI that comes with STM32 Dev. And yeah, understand I can flash without using the STM32 programmer. It's just where I currently am. As I said, it's very methodical. I get something that's working, and then I just do one change at a time and just build up from that. So it's slow, but it works, and I can always trace my steps until I get comfortable. Anyway, thank you very much for watching this, and yeah, I'll hopefully be coming out with some more videos soon. Cheers, have a good night.